This booklet that you have is going to cover a couple days worth of information. We're going to do the first few pages together in class, so this video is really more for if you missed that or you need a refresher. And then these last ones, these last two, are going to be the second day's worth of class. That'll be a second video. And then we're going to keep these last couple pages blank so you can add any notes that you need to, or re-summarize or rephrase stuff so that everything you need to know about exponents is all in here. Okay? So let's start with the product rule. And the first thing it asks is, what's the difference between 3x and x to the third power? Well, the important thing to remember here is that 3x is 3 times x, but x cubed is x times x times x. Another way to write this top one is just x plus x plus x, whereas this is x times x times x times x. Exponents are repeated multiplication. Okay, exponents are repeated multiplication. Okay, so when I'm working with multiple exponents, I have to keep that in mind. So 2 to the second power times 2 to the third power. So we can always do this. So I'm just going to expand it out, write what it means. So this 2 squared, those are these two. And then there's 3 2's. So altogether, that's 5 2's. I could multiply that out. 2 to the 5th power actually isn't that bad. It's just 32. But like when I look ahead to this 11, I don't even want to multiply that out 6 times and then 8 times and then multiply those two together. So simplified exponent form is going to be a lot easier to deal with. Okay, so let's check here. 3 to the 4th. 1, 2, 3, 4. 3 to the 5th. 1, 2, 3, 4, 5. So how many 3's are we multiplying? 1, 2, 3, 4, 5, 6, 7, 8, 9. Equals 3 to the 9th. 11 to the 6th and 11 to the 8th. Well, based on these two, you've probably already noticed what's going to happen. Here I had 2 plus 3 equals 2 to the 5th. Here I've got 3 to the 4 plus 5 equals 3 to the 9th. So instead of writing out all of these 11's, I'm just going to write 11 to the 6 plus 8 equals 11 to the 14th power. Okay? Again, expanding always works. I could write that out if I wanted to. So like right here, 5. 1, 2, 3, 4 5's. 1, 2, 3 more 5's. So all together, that's 5 to the 8th. And here, 9 x's and 7 more x's, so we're going to end up with x to the 16th power. So our general rule, we need a way to write this so that we can just kind of plug things into it later on. We used over here a to the b, just to mean some number as a base and some number as an exponent. So if I have a to some number times that same a to maybe some other number, then I can write a to the n plus m. Okay. Same base, that's important. Okay, so if we're multiplying, add exponents. Okay. Why is it called the product rule? Well, because product means multiply. And it's the rule we are using when we multiply things together. our generalized rule, we're going to write this down because this is the kind of information you're going to see if you go to try to look it up somewhere. A to the n times a to the m, a to the n plus m. And so again, the a's are all the same because that number has to be the same. These are different, not because they have to be different. I could do 3 to the 4th times 3 to the 4th and still get 3 to the 4 plus 4, which is 3 to the 8th. But they can be different, and that's why we use different letters here. Okay, let's turn the page. Quotient. Well, quotient's what we do when we're dividing, right? And so multiplication and division are opposites. So instead of adding, you can kind of guess that we're going to subtract. We're still going to expand. 2 cubed, there's 3 2's on top. 2 squared, there's 2 2's on the bottom. Now when we simplify this, remember that the reason I can cancel this 2 with that 2 is because 2 divided by 2 is 1. And 2 divided by 2 is 1. So I have 1 times this only 2 that's left over. So I write there's 2 to the first power because there's only 1. Okay, same thing here. We're going to expand 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3, 4. So when I see what's the same top and bottom, because they divide to 1, that leaves me with 3, 3, 3, which is 3 cubed. Okay. So I can write out my 10x's, but do we want to? Okay. Here I had 3 minus 2 equals 2 to the 1. Here I've got 3 to the 7 minus 4 equals 3. So let's just do x to the 10 minus 4 leaves me x to the 6th. And we'll try it down here. We'll just do it twice. 5 to the 12 minus 7 and y to the 20 minus 8. And I got 5 to the 5th, y to the 12th. Okay, so again, we're going to say when dividing, subtract exponents. So we've got x to the n over x to the m, because again, they have to be the same. Okay, just like we used a before, we could come back in and make these all a's. That's totally acceptable. Whatever letter you want, they just all have to match. N minus m. Okay. And now this takes us to something interesting, the zero exponent rule. And remembering this will save you a lot of trouble later on. So if I look at 2 to the 3rd power over 2 to the 3rd power, well, if I expand it, that's 2, 2, 2 over 2, 2, 2, which is everything cancels. But remember, when it all cancels, it equals 1. So when I look at it 2, and I use my quotient rule, 3 minus 3, that leaves me 2 to the 0 equals 1. Well, what's anything divided by itself? 1. So here again, I've got 5 to the 7 minus 7 leaves me 5 to the 0. Anything divided by itself is 1. So x to the 20 minus 20 is x to the 0, 1. Anything to the 0 power, it's the same as saying, what is this number divided by itself? 1. Always equals 1. Okay. Anything you can think of raised to the 0 power, always 1.